All right, so here we're going to talk about kind of a trick, shortcut to doing binomial expansion. So we're going to use this thing called Pascal's triangle. So I'm not going to go into great detail of the Pascal's triangle in this video, just to conserve time. If you are interested, there are a lot of videos, actually a lot of cool videos out there about Pascal's triangle. Just patterns that we see in the world and other things, kind of cool. So the first thing, just Pascal's triangle. So it's here on the right hand side. We're just taking the sum of the numbers and putting that value in the middle. So 1 and 1 is 2, 2 and 1 is 3, 3 and 3 is 6. So it just keeps feeding down and just never ends. So row 6. So here's row 5. So what we're going to do is go ahead and add these up just to get 6 and 7. So row 6 would be, so we always start with 1. So we have 6, because of 1 plus 5, and then 5 plus 10. 15, and then 20, 15, 6, and 1. Okay. And then row 7, we're going to add these. So we have 1, we have 7, 21, 35, 35, 21, 7, and 1. Okay, so that would be the 7th row. Get 8th row, we can just keep going on forever. So what we're doing with these is the power of the binomial is what level we're on. So power of 0, this is the 0 level. We just have 1. And then as we go on, we keep moving down Pascal's triangle. So this, we talked about this in the other video. This is that equation that we had for a plus b quantity cubed. So we can look at any further equation. Now notice we have our coefficients, so 1, 3, 3, 1. There's a 1, a 3, a 3, and a 1. 1, 4, 6, 4, 1. We have it right here, 1, 4, 6, 4, 1. So that's where those numbers come from. The other part of this, what we do is we start off with the, so let me go to the fourth one, 4th power. So we start with our 2 variables on either side to the highest power, so a to the 4th and b to the 4th on both sides, and we work our way in towards the middle. We're reducing the power of that variable as we move to the middle. So a to the 4th, a to the 3rd, a squared, a, and then the last one would be a to the 0, which is just 1, because we know any value to 0 power is 1. We do the same thing with b. Move to the left, we reduce the power, and we'll have our equation. So now let's go ahead and utilize that. So use Pascal's triangle to expand each expression. So our a value is y, and our b value is -3. Okay, we're going to use the 4th level, which is the 1, 4, 6, 4, 1. So right here, plugging in our values, so we would end up with y to the 4th. We have plus 4, and I'll just write it out. 4 times a cubed, so a cubed, that's y cubed, so we're reducing, and then times, we have our b value, so -3. So I'm going to write that in parentheses there. Okay, then we move on to the next one. We have a 6 as our coefficient, and then y squared, and then -3 squared. So we're reducing the power of y, and then we're increasing the power of -3 as we go to the right. So 4 is the next one. We get y times -3 cubed. And then lastly, we get a 1, so we don't need to write that, and then just negative 3 to the 4th power. So that's how we use the equation, Pascal's triangle. So we just clean this up a little bit. So we end up with y to the 4th, negative 3 times 4, so minus 12, y cubed, plus we get negative 3 squared would be 9, and then 9 times 6. So 54 y squared, and then negative 3 cubed is 27 times, well, negative 27 times 4 would be negative 108. And a negative 3 to the 4th is 81. So that would be our equation. So like I said before, this is an optional method. You could write out y minus 3 4 times and multiply it all together. Just is going to take some time. This is definitely much quicker. So last one, we have a value is 4z, and our b value is 5. So we have third power, remember, so we're using the third line. So a to the third. So 4z. Now we gotta be careful when we have multiple things here in our term. So we have to cube the whole thing. Plus 3 a squared b, so we're multiplying by 5, plus 3 times 4z. It's to the first power, so I'm not going to write in parentheses, we don't need to. And then multiply by 5 squared. And then we're adding 5 cubed. So let's go ahead and simplify this real quick. So 4 cubed, so we have to cube the 4 and the z. So 4 cubed is 64. Z cubed plus, at the square first, so 4 squared is 16 times 3 would be 48. Z squared. Still got to multiply by 5, so 48 divided times 5. So 48 times 5, well, I'm just going to write that down. So 3 times 4 is 12 times 25, so we get 12 times 25 out front. We'll have to clean that up later. And then 5 cubed is 125. So just to conserve time on the video, you're gonna do 4 times 5, clean that up, and then 12 times 25, and then that would be your coefficients. I want you to try. I'm gonna do one of the checkpoints right now, so do the second one just because it's a little trickier. Let's go ahead and pause and try that. All right. So I'm gonna do the setup, and then you can simplify it after that. But we just need to make sure that we have, so 4th power, we're dealing with the 4th line. So we have 3x to the 4th. So we need to make sure we do 3 to the 4th and x to the 4th. So plus, so our next one is a 4, okay? So 4 times 3x cubed, and then we're multiplying by 1. So I'm just going to write it in there just to show you, but it obviously does nothing. So plus 6 times 3x squared times 1 squared, which again is not going to do anything, plus 4 times 3x times 1 cubed, and then plus 1 to the 4th. So if we clean that up and simplify it, we'll have our answers. So let me know if you have any questions on that. Again, this is an optional process. You can write these out, expand it, and then do it manually, multiply it out. If you have any questions, let me know.